Alright, this is the video lesson for Unit 13, Rational Expressions. And what a rational expression really is just an algebraic fraction, an algebra fraction. So to start out here, I want to review just some fraction work in general here with examples 1, 2, and 3. So when we are supposed to simplify a fraction, what you're actually doing when you simplify a fraction 12 over 15, and now I know most of you guys are just going to say, okay, well 12 over 15, they're both divisible by 3, so that's going to give me the answer of 4 over 5. And that is true. That is correct. But again, what you're really thinking is you're thinking, or what you should be thinking is you should be thinking factor. And that's going to be important. Factoring is going to be a huge part of this chapter. So if you remember factoring back in chapter 9, that's going to be very helpful for this chapter, because what you're really doing here with 12 over 15 is you're factoring 12 into 4 times 3. And then you're factoring 15 into 5 times 3. And then you're canceling this common factor of 3, leaving you with your answer 4/5. So that's actually what happens when you simplify a fraction, is you're actually factoring it and then crossing out the like, or the common factor. Now, when you cross multiply, again, we're thinking the same process. 12 over 15 times 1 over 2. What you can think here, though, is that you can, besides just normal canceling, you can cross cancel. So, you know, if you wanted to, you could start here with the 2 and the 12 and turn this into a 1 and a 6. And then what you have now is you have 6 over 15 times 1 over 1. Well, 1 over 1 is just 1. So you just have 6 over 15, and 6/15 cancels, both divisible by 3 again. Final answer of 2/5. So if you notice in that problem, we started by cross-canceling, then we canceled what I call just above and below, you know, the two common factors right on top of each other. Alright, and then our last review problem on basic fraction work is how you divide fractions. And right here in the hint, we've told you to, you know, what you need to remember about dividing fractions. And that's when you're dividing a fraction, you're actually multiplying by the reciprocal. So I have to first change this problem into 12 over 15 times 2 over 1. That's the multiplying by the reciprocal part. And then, again, at this point, you have choices. You could cancel the 12 over 15 the way it is right now, or you could multiply straight across. I'm going to choose to cancel the way it is right now. So 12 over 15 turns into, like we did earlier, 4 over 5. And now I'm going to multiply straight across here, and I'm going to get we're going to get 8 over 5. So there you have it. There's our little review of simplifying fractions. Now, what we're going to do down here on the rest of the notes is we're going to simplify fractions. The only difference is our fractions are going to be algebraic fractions. They're going to be algebra problem fractions. So let's go down here and look at example 1 and 2. Okay, and if you read my little sentence there for lesson 1, it says, now that you have reviewed fraction work, try some variables, try some with variables. And it says, and this is the important part, when you have a binomial or trinomial, you need to think about, sorry, I'm trying to find another color here. You need to think factor first, okay? Binomials and trinomials, you're going to have to factor, and that's what I was saying, that if you remember how to factor from chapter 9, this is a pretty easy chapter. So excuse me, example 1 here. We've done these problems before. This should just be a review problem. You have a monomial, 35y x squared, over another monomial, 14y squared z. So we're just going to cancel. We're going to follow these 2 steps. Reduce the numbers. So reduce your numbers and reduce the variables. So our numbers first, 35 over 14. What are they both divisible by? Well, they're both divisible by 7. So they're going to cancel into 5 over 2. 7 goes into 35 5 times. 7 goes into 2 twice. And then our y's. The top y is to the first. The bottom y is to the second. So I can cancel one of them, leaving me with 1y in the denominator. And again, you don't have to write that 1. Just a single y is left in the denominator. In the numerator, I had x squared, and there were no x's to cancel with it, so x squared just stays in the top. And in the denominator, z had no z's to cancel with, so z stays in the bottom. And you are done. Alright, now, number 2, this is the new problem. This is the new problems from this lesson, and this is where you need to first step is to always think factor if you're dealing with a binomial or trinomial. So, how are we going to factor this? How are we going to factor this trinomial? Well, you're going to factor it the same way we've always factored, right? You're going to set up a little table. You're going to say, I'm going to find 2 numbers that multiply to make 9 and add to make the middle number -6. So that's going to be -3 and -3. And again, since this is a 1x squared problem, I'm going to use my shortcut, and I'm just going to rewrite this trinomial in factored form as the binomial x minus 3 times another x minus 3. Now I'm going to do the same thing with the denominator. I'm going to try to find 2 numbers that multiply to make -15 and that add to make +2. That's a little bit more tricky, but I think +5 and -3 should work. And again, since this is a 1x squared, the factored form is just going to be x plus 5 and x minus 3. So, step 2 then says to cancel like factors. So if you notice here, our like factors are the x minus 3 in the numerator and the x minus 3 in the denominator. Now, it does not matter which 2 you cancel. You could cancel the last 2, or you could cancel the first one with the bottom one. What you cannot do is you cannot cancel all 3 of them. Okay? You can only cancel 1 from the numerator with the 1 from the denominator. So I say this x minus 3 cancels with this x minus 3, leaving me with a final answer of x minus 3 over x plus 5. Now, this is my final answer. And another thing I see a lot of people do wrong is that they want to cancel this x with this x. They want to mark this x out, and they want to mark this x out, and say the answer is -3/5. Well, you can't do that, because you got to remember that these are binomials. This is the binomial x minus 3 and the binomial x minus 5. So in other words, you can only write, or you can only cancel entire binomials with other exact same binomials. So don't cancel just pieces of a binomial. Same thing here. Don't try to cancel, this -3 with this 5. If they were both divisible by the same thing, you still couldn't cancel those because they're part of the binomial. You cannot cancel just pieces of the binomial. Or for that matter, you can't go back here to this original problem. This original problem right here, another big mistake is people that just cancel out the x squared with this x squared, and then cancel the -6x with the 2x. You can't do that because these problems, this is a trinomial over another trinomial. You cannot cancel out pieces of the trinomial. You can only cancel factors, and that would be these x minus 3s that were in common after you factored the trinomial. So that is the big, main part of this lesson, is you can only cancel out factors. You cannot cancel out pieces of a binomial or trinomial. Over here, you can cancel out pieces because we're just canceling out pieces of a monomial. They're all their individual factors. It's 35 times y times x squared, and then over 14 times y squared times z. So you can cancel those all out. All right, very good. Let's move on to the next set of problems. Okay, for this next two examples, if you read my lesson 2 rules here, it says same rules as lesson 1. So again, these two problems are going to be done the exact same way as the first two problems were. And it says to remember that you can cross out factors up and down or on the diagonals when we're multiplying. So really what it's reminding you is that you can cross cancel as well as just simplify. So let's go down here and look at number 3 and decide where we can cancel. So a lot of choices here. Let's start with just the numbers. You could cross out the 10 and the 35 because they're both divisible by 5. You could cross out the 10 and the 6 because they're both divisible by 2. You could cross out the 6 and the 42 because they're both divisible by 6. So again, lots of choices here. You just need to continue to cancel and simplify until you can't anymore. I think I'm going to go ahead and choose to cross cancel. So I'm going to cancel out the 10 and the 35, and I'm going to get 10 and 35 are both divisible by 5, so I have 2 up here, and I'm going to have a 7 down here. And then I'm going to cross out the 6 and the 42. They're both divisible by 6, so I get a 1 down here, and I get a 7 up here. Which, right now, I can go ahead and already see that I'm going to be able to cancel out my 7s too. But I'll wait for another step to do that. So, again, as we're doing this, we're doing steps 1 and 2 together. We're cross-canceling or canceling, it's your choice. So now I'm going to go to step 3, which is now cancel out my variables, again, by cross-canceling or canceling above and below. So with my variables, I'm going to say, okay, I have 2 n's in the numerator right here, and I have 3 n's down here. So that means I can cancel out 2 of them, leaving me with 1 n right there. And then r's, there are 3 here and 3 here, so I can cancel out all 3 of them, leaving me with no r's at all. So now I've canceled everything from my original problem, and this is all I have left down here. So I have 2 over 1n times 7 over 7. Well, at this point, I'm going to cancel my 7's and say 7 over 7 is just 1 over 1. 1 over 1 is the same as just 1, so really it's just 2 over 1n times 1, which is obviously just 2 over n. Done. And again, this is something that you should have probably already kind of done. We have simplified monomials before already, so that one should have been pretty easy. Now number 4, this is kind of a new problem for us though, because we have fractions that have all of these polynomials on it. So remember, these are polynomials. This is the binomial n squared minus 16 over the binomial n plus 4. Over here I have n plus 2 and over n squared minus 8n plus 16. Remember, keep in mind, you are not allowed to cancel the 16 and the 4. You are not allowed to cancel the 16 and the 16 or the 4 and the 2. You cannot do any of this because that would be canceling out pieces of your binomial or trinomial, and you can't cancel out pieces. You can either cancel out whole entire binomials or whole entire trinomials, but not pieces of it. So what we do need to do anytime we see binomials and trinomials is we need to think factor. So we're going to factor all of this first. And what I'm going to do here is I'm just going to completely rewrite my two fractions. I'm going to have this fraction times this fraction, and I'm going to start here with this right here. N squared minus 16, you need to recognize that as a difference of squares and realize that it turns into n minus 4 times n plus 4. N squared is a perfect square, 16 is a perfect square, and you have a negative in the middle. That makes it a difference of two perfect squares. So n minus 4 times n plus 4 is the first numerator. The first denominator, though, n plus 4, just stays as it is. That can't be factored. So it just stays as n plus 4. Same with the first numerator of the second fraction. It stays just n plus 2. But the denominator, here's a trinomial, so I'm going to have to go through my factoring steps. I'm going to find numbers that multiply to make 16 and add to make negative 8. Well, that's going to be negative 4 and negative 4, right? And again, since it's a 1n squared, here, you can use your shortcut method. And I'm just going to write the binomial n minus 4 and another n minus 4. Now again, all I have left to do now is cancel, and you're going to cancel like binomials. So in other words, this n plus 4 can cancel with this n plus 4. This, oh, let's change colors there. This n minus 4 can cancel with one of these n minus 4s. Again, remembering not both of them, just one of them. And then you just, in this last step here, write out what's left. You know, and that's your final answer. So my final answer here is n plus 2 over n minus 4. Done. And again, keep in mind, you cannot cancel your 2 and your 4. You cannot cancel your n and your n, because these are parts of a binomial. It's the binomial n plus 2 over the binomial n minus 4. Done. So again, this should be, you know, a very easy, relatively simple section to learn and hopefully do well on the test with. Alright, so let's move on. Alright, so here are our last two examples. And again, I called this lesson 3 because this is the last little switch, little change, and this is when we're dividing fractions. And you got to remember that when you're dividing fractions, to flip the second fraction and multiply. So again, all this is saying is that we need to multiply by the reciprocal. Okay? We're going to multiply by the reciprocal in this case. Alright. And then again, it's the same rules as all the other ones. So the only change to this section is to multiply by the reciprocal. That's the only change. So I'm just going to start this first problem out by rewriting it. 6x to the 4th over 5 times 75 over 24x. As soon as you've rewritten it, you have the exact same problem as we did in the last section. I'm going to cross cancel the 5 and the 75. That's going to give me 1 and 15. I'm going to cross cancel the 6 and the 24. That's going to give me 1 and 4. I'm going to cross cancel 4 x's with 1 x, so I can cancel one of these x's away. That's going to leave me with 3 x's up here. And now I just rewrite what I have. Right here I have 1x to the 3rd times 15, which is going to be 15x to the 3rd, over 1 times 4, which is 4. And since nothing else can cancel here, there's nothing that can cancel there, I'm just done. Alright, very good. So that was example 1. Pretty easy. Or example 5. Example 6 here, again, if you do not see two fractions, you have to recognize that there are two fractions. This is this fraction right here being divided by this fraction right here, x minus 3 all over 1. So again, I'm going to start this out by just rewriting it. I'm going to say 12x minus 36 all over x minus 7 times 1 over x minus 3. Now, what I need to do at this point is I need to factor anything and everything that can be factored. So I'm going to move this up here. So I'm going to factor 12x minus 36 by taking out the GCF of 12, which is going to give me 12 times x minus 3. And then nothing else in this problem can be factored. So this is over x minus 7. I have times 1 over x minus 3. Looks like the only thing that's going to cancel here is this x minus 3 with this x minus 3. So I have 12 times 1, which is 12, all over x minus 7. Done. Alright, so that's pretty much it for video 1. There are 6 example problems below this that I want you to work out on your own, or if you're in class and we're doing this in class, we're going to be doing these 6 example problems below here together. But if you missed class and you're watching this video on your own, you need to do those 6 example problems. You can check your answers with the PDF file on Moodle that says Unit 13 notes completed, and the completed notes will have the answers to the next 6 problems. There is still one more video after this, so video part 2 is what you'll need to watch next.